Hi everyone. Okay, let's finish up this lesson. So if you recall, we talked about the steps to solving quadratic problems and converting words into quadratic equations. We said that usually you'll be asked for one of two things, either to solve for x-intercepts or the vertex. You will need to know some very basic formulas like revenue is price times quantity sold, and things like area is length times width. So in the first one, we created a function for revenue and we found the vertex by finding the zeros and then averaging them to find the axis of symmetry and then finding the vertex from there. We did that again with this area question. And then with this question on two numbers that add up to 18 and multiply to get a product. In this case, we didn't need the vertex. We did need the vertex, but we also needed zeros. This was the one where we didn't need the vertex. We just needed the zeros, and we ended up getting two answers. Okay, so in this question, we'll notice that we don't need to make up the formula. It's given to us already, okay? Owen and James made a toy rocket in their math class. They want to show their teacher how far the rocket can fly, so they climb onto the roof and launch the rocket. I do not recommend that at home. The flight of the rocket is modeled by this function, h of t equals negative 5t squared plus 20t plus 60, where t is in second, time in seconds, and h is the height in meters. So it says, how long after launching did the rocket hit the ground? Now, I know this is a parabola. I know it's facing down. So I know it's going to have a shape that looks like this. So basically what it's asking me is where does it hit the ground, aka it's asking me where the zeros are. So when I get this function, I could use polysolve, or if I factor out the negative 5, I believe this is factorable. I need two numbers that multiply to negative 12 that add to negative 4, and those are negative 6 and 2. All right, so t minus 6, t plus 2. So what that means is my zeros are at t equals 6 and t equals negative 2. And because these are seconds, I know that one doesn't make any sense. The rocket hits the ground at 6 seconds. All right, so we could write like 6 and negative 2 here. So what that means is my graph actually looks something like this, where time is 0. So this is time, and this is h of t. So that graph kind of helps me realize the second part of the question, which says, what is the height of the rocket at the time when it is launched? So it's launched at t equals 0 seconds. So essentially it's asking me what this point is. It's asking me what h of 0 is. So what I can do is I can start with my factored form, or I can go back to the original function. But what I'm doing is I'm subbing in 0, and you don't have to write all this down. Okay, I think seeing that it's 60 is something you can do without subbing in the 0 the way I did, doing all that work. So you can say the rocket is launched from 60 meters high. All right. Alrighty. Let's have a look at the last one. Ooh, your favorite fast food restaurant is, you can put in whatever you want there. Let's say Hero Burger. Might not be my favorite, but for today it is. Okay, sells an average of 250 orders of onion rings each week with a price of $150 per order. Some customers are complaining that they are too expensive, so Clark Kent, oh wow, wants to please his clients. He thinks that for each 5-cent decrease in price, 10 more orders will be sold. What should the new price be? Okay, so we said the first step is a let X represent statement. And we also said with questions like this, what we should do is talk about the number of price changes. Instead of talking about increases and decreases, if we just talk about price changes, we could use the same sentence every time we get a question like this. Okay, so step number 2 is to use our formula. And in this case, we know that revenue, we can just call it revenue, equals quantity sold times price. Okay, and if you want to pause the video and think about the equation before I write it down, that's great if you want, or we can just write it down. We're going to get 250 plus 10x. 10 more orders will be sold. $1.50, subtract a nickel every time. Okay, now maximizing revenue means we have to find the vertex, but to find the vertex, first we need the zeros. And I look at these values to find the zeros. So x equals negative 25 will cause the first bracket to be 0. We can call that x1. x2 is, and I'm going to get out my calculator, 1.5 divided by 0.05 gives me 30. Okay, so from here to find the axis of symmetry, I add and divide by 2. So I know my axis of symmetry will be 2.5. So what that means is I change my price 2.5 times. I'll add 2.5 nickels, subtract 2.5 nickels from the price. Sounds a bit weird, but we can round these things as well. All right. So the last part of this is finding. So we have XV, but we need to find RV. We need to find the maximum revenue. So what I'm going to do is take 250 and I'm going to sub in XV for X. I'm going to take 1.5 and this. I'm going to sub in XV. So let's see what we get. All right. So this ends up being 275. And then, oops, I missed a 0 here. Okay. Okay, so this becomes our new quantity. Okay, and this becomes our new price, which we could round to $1.38. But our question is asking what the revenue is, so we can leave all those decimals in there and multiply by 275. So our new revenue is 378,125. If we put it in our sentence answer, we will round that decimal. So the max revenue is 378.13. Okay, so we have some homework and I have a little take-home quiz for you guys to do. All right, good luck and see you next time.